Hi there, I'm Clifford Bates, and welcome to what this is a new thing. I'm just experimenting with this. This is what people have asked me to do about political science, and I'm going to, as a political scientist, I've been teaching methods now for 20 years over here, over 20 years over here, both for international relations and political science students. Um, so I have an idea of how to kind of like basic introduction to research. I'm going to be this series of kind of political science methods, research methods, right? Will be small. It'll be quick, and I think I'm gonna do it for a week. It's gonna be like a week based, maybe 2 weeks, because I'm going to do very short things. I'm going to break up. I'm only be looking at two chapters of this because I think this is a small book. This is a very small book. This is Stephen Van Evera's A Guide to Methods for Students of Political Science. It's a classic book. It was published like I think in the late '90s. He was a professor at MIT, and he had a research. He got stuck teaching these methods course. He's an international relations person, studies IR theory and IR politics, but war and things like this. And he was often teaching the methods course, and he wrote a little handbook that everyone really liked, and it was published by Cornell. I ran into it by accident because I was looking when I was first coming. They asked me to teach methods. I was not a methods guy. I'm a political theorist, not a methods. But no one else here really knew methods in a sense that political. Most of it was kind of like secondhand sociology and journalism. So I asked, or either literature people, American studies, or mostly history people, or there were some historians and some literature types with one or two sociologists, but they were more modernist. There was a more traditional sociologist, but her approach was still historiographical. And a lot of the students wanted we had to help them make a hypothesis and things like this. So therefore, this is one of the things that I had to learn. I had to teach it, and I did it as undergraduate. I both undergraduate and graduate took methods course. I despise them as a rule because usually they're taught badly by teachers. Even I had a good teacher, Dr. Hyde, who was a decent guy, but they always tended to conflate statistics to having basically throwing down stats down to students' throats, quantitative methods down students' throats, and statistical modeling down students' throats. Both he and Dr. Hyde at my undergraduate school, and then Professor Wyckoff at NIU. I forget. Um, I think Hyde was at Providence was a much better teacher than Wyckoff. Okay, oh my God, how dare you say that? But no, I think so. And also as a researcher, I think he would be. I haven't really seen them out like this, but I remember his work on this was. There was a sense of that his research and his interests were more serious in that sense. And I thought generally in other subjects he was a better teacher than Wyckoff. From what I saw, I didn't take any Wyckoff class except this because I was turned off by it. But again, I didn't do method. So okay, today I'm going to be so therefore I taught myself method by studying Whenever and other books. And I came to suggest that it was very good. This was Whenever's book is a classic, I think, argue. And therefore, I use it always in my introduction to method courses, and when I'm part of the so-called team taught methods course, where I have to do 3 sections of, I usually on political science methods, will use whenever, as I will focus today mostly on the 2 chapters. I might, not today, but in the series one on the 2 chapters, maybe I'll do the 3rd chapter as well because it's going to be I'll treat it by itself because I think it's more about dissertation and what is done in dissertations and things like this. So let's go. Guide to methods for political science. Guide for methods for students of political science. Now, he says this. He talks about them. I'm going to talk about this. He goes, "This is not definitive, right?" He says, I things he gave in the classroom and hallway discussions in my neighborhood. I wrote them with graduate student readers in mind, but others may find them useful. I began a how-to handouts that I drafted to save me further explaining of oft-repeated advice. Right, any advice I began remembering more than once, however mundane. Begin paragraphs with topic sentence, qualified for inclusion. At the same time, I omitted standard advice that I rarely had to give. Right. Thus, this book is not exhaustive or definitive. I make no effort to cover methodological waterfront. Made a mission. I have a chapter. I have no chapter on large N methods. Right. Now, large N means large N. N, the small word N in this means the number of cases. And he has, in fact, some people, oh, yeah, don't have large N. Well, to be honest with you, most young starting scientists are not going to be doing large N cases. They're going to be doing small things. Now he says, on footnote 1, he says, many good primers on large efforts appeared, so my absent chapter will not be badly missed. I list some in chapter 1, note 32. Missing here are chapters on rational choice. In other words, also missing in his book is chapters on rational choice, critical, postmodern, and constructive approaches. For friendly discussions on rational choice, see John Elster's Rational Choice, and also Elster's other books. Elster's The Nuts and Bolts of Social Science, or else is explaining. These are kind of very good books. Jeffrey Friedman's Rational Choice. Critical discussion include Donald Green and Alan Shapiro's Pathologies of Rational Choice, an application Yale. And he says, and he goes into different rational choice arguments and like that. He gives all the critique of this. Now, all my 6 chapters are primers in my states my personal nothing I claim. No, he says like this. The views expressed arise from practicing methodology, then studying it. In other words, they reflect my experience as a student, a colleague, a teacher, and editor. I learned some important things writing on philosophy of science and social science method, but I have found much of that writing obtruse and unuseful. It was much easier to invent my own answers than dig up them from reams of muddy archine produced by philosophers and methodologists, even when the answers existed somewhere in those reams of material. Now he says, this book reflects my concentration of international relations security affairs. It focuses that are greater in IR security subfields, for example, case study methods. And its examples are IR heavy, right? I hope it nevertheless proves useful to students in other political science fields and the other social scientists. My regret in advance for readers from those fields for its patriarchalism, which stems from the origins of a collection of class handouts, right? And he goes, these are the chapters. We're going to be looking at this. And then chapter 2 about case studies. Chapter 1 we'll be focusing up now, we'll be breaking up a couple small videos, hypothesis, laws, theories, a user guide. And chapter 2 is what are case studies and how they should be performed. And the third chapter I might do is what is a dissertation, describing the nature of a dissertation. So let's go into chapter 1. And focusing today, mostly we will look at what is a theory and what is a theory? Theory and explanation. Okay, I want to be doing this. Definitions of a theory offered by philosophers of social science, critic and diverse. I gives a whole long paragraph. Most posit that theories explain phenomena and leave it as that. The elements of an explanation are not detailed. And he gives into the in other words, and from reading from that book, a social theory is a systemic, unified expression of a diverse range of social phenomena. Likewise, Earl Babel, a theory is systemic explanation for observations that relate to a particular aspect of life. Um, Also, see Kenneth Waltz noted each leaves the components of the explanation unspecified, leaving even explained unmentioned, leaving even explanation unmentioned. Philip Sheridan's Crafts of Political Research, which is a decent book. A theory takes a set of similar things that happen, say a development of party system and democracies, and find a common pattern that allow us to treat each of these different occurrences as a repeated the same thing. Right now, I recommend following a simpler framework. Now he said I gave you that. Well, I read that thing because he's going to say no. I'm not. He's going to recommend following a more simple framework that captures their main meaning while also spelling out the elements that these things often emit. So therefore, what is a theory? He goes, theories are general statements that describe and explain causes or effects of classes of phenomena. In other words, it explains the causes or effects of classes of phenomena, types of groups of phenomena. They are composed of causal laws or hypotheses, explanations, and antecedent conditions. So, therefore, the basic concept of a theory is a basically expecting something causal, right? Causes or effects. Okay, cause and effect of things in the world. Okay, they are composed of a theory is composed of a causal law. A law. This is a term specific. A law. This is this is a law. Is we'll explain it next thing. Right. He goes an explanation and antecedent conditions. Explanations are also composed of causal laws or hypotheses, which are in turn composed of dependent and independent variables. 14 is these 14 definitions bear mentioning now. In other words, he says that what is this? An explanation is also understand are composed of a causal law or hypothesis, right? That in other words, you have to explains it right there, right? Law. An observed a law is an observed regular relationship between two phenomena. Laws can be deterministic or probabilistic. So therefore, what does that mean? Deterministic means this causes that, or this is likely to cause that. Deterministic means 100%. I mean, there's no doubt. A does this, only that, or it does not do that, and nothing else. Okay, or other things. So it does or does not do that. That's deterministic. Probabilistic is this may do this bias likely, or in other words, it's not certain, or deterministic implies certainty in that sense. The former frame, the former frame in invariant, the former frame invariant relationships. In other words, the law is between two phenomena. The former frame relationship, if A, then always B. In other words, deterministic, right? The former, deterministic, is if A, then always B. The latter the latter frames probabilistic relationship. If A, then sometimes B with a probability of X. I'm a percentage. That out of so many times. The odds of this happening. What is the percentage that it's going to happen? Hard science has many deterministic laws. Nearly all, in other words, hard sciences have deterministic laws. Nearly all social science laws are probabilistic. Okay, again, this is different. The difference in, and that's the big difference in when he says social science and hard science. Hard science is there tends to be, the assumption is that things to be deterministic. Social science tends to be more probabilistic in this sense. Causal laws can be caused A causes B, or non-causal. A and B are caused by C, hence A and B are correlated, but neither causes the other. In other words, A causes B, that's a causal, and non-causal is A and B are caused by C. Hence, A and B are correlated, but neither cause the other. So that's non-causal. This causes this, that's causal. But these two, there's no causality here. They're correlated. They're occurring. They are both occurring, but there's no direct aspect of cause to this, right? Our prime search is for causal laws. In other words, we look for causal laws more than non-causal, right? We explore the possibility that laws are non-causal, mainly to rule it out. So we can rule out the possibility that observed laws are causal. In other words, we test to see something as non-causal, only so that we can rule it out. And that's because we're looking mostly for causal. A causes B. Now it can be caused as again deterministic or probabilistic, but it's still a cause that this affects that. Not that this does not affect that, or we don't know about this, right? It's correlations. A generic law, which might be called causal or non-causal, should be stated in an associative language. If A, then B, or the greater A, the greater B, or the higher A and the smaller B, etc. Causal laws can also be framed with causal language. A causes B. So therefore, if A, then B, or A greater A, then greater B, the greater B. In other words, these are the relationships. Or they can be from A causes B, right? 3, causal laws assume 4 basic causal patterns. Now, this is something he's a note. It's a thing. He goes, direct causation. In other words, these are the 4 causal patterns. That direct causation, A causes B. That's one. Reverse causation, B causes A, right? Reciprocal correlation, A causes B and B causes A. Reciprocal, this is, again. And undetermined causation, A causes B and B lessens A, right? So undetermined correlation. So A causes B and B lessens A. It makes A less strong. So that's an undetermined, undetermined. Yeah, undermined. Sorry, I'm reading this. Self-undermined causation. In other words, A causes B, and B makes then weakens A. Hypotheses discussed below can assume the same format. So, theory, in other words, causal laws and hypotheses are kind of similar in this, like this. So, our theories and causal law that he's saying. To establish a specific causal relationship, A causes B, we must rule out the possibility that the reserve causal, in other words, to set this up, we must we must rule out the possibility that the observed relationship between A and B is spurious. In other words, to establish that this is this, we must see maybe C causes A and B, something else causes A and B, right? Or a reverse causation, that B really causes A, not A causes B, okay? We may also investigate whether reciprocal causation or self-undermined causation at work. So is reciprocal, in other words, reciprocal is A causes B and B causes A. That's really, so in other words, if we're looking for this, we have to exclude that, and then we want to watch for these two, right? And these are at work, okay? This is a very good the note here, good on causality, okay? I'm sorry for the handwriting. I didn't have a good clean copy of this. Hypothesis. Now, we went from a law to a hypothesis. Hypothesis. A conjectured relationship, or unconjectured, unproven. It's assumed. A conjecture is an educated guess. Okay? A conjecture is it's kind of an educated guess. It's kind of like I have an idea what it is. It's not a mere guess. It's an educated guess. A conjecture. I mean, Now he says unproven. Yes, it's unproven. Conjecture does not mean conjecture is I'm kind of I don't know I don't know what's true or not true. I'm not certain about that. I have no certainty about its validity or invalidity. Okay, but I think it's true or I think it's false. Right? A conjecture, a conjectured relationship between two phenomena. Now I'm going to stop here, and he goes. It follows that hypothesis is a conjecture about the relationship between two or more concepts. Right. Heppel uses hypothesis more broadly to include conjectures about facts and relationships. So he goes, for Heppel, descriptive conjectures, for instance, the estimates of the height of the New York Empire State Building or the size of a national debt are also hypotheses. Hempel's is that I use the term presupposition to refer to what Hempel calls hypothesis. For me, propositions can be hypotheses or descriptive conjectures. Babby also uses hypothesis broadly. Under hypothesis, he concludes predictions inferred from hypothesis, which I call predictions, observations, or in other words, he's going to use it more narrowly. In other words, I agree with Van Evera because other people use it more broadly and it becomes confusing. A hypothesis should be more narrow. It is that what? It is aiming at the conjectured relationship between the two phenomena that we're looking at. Right? Theory, a causal law. I have established, in other words, causal law. A theory is a causal law. I have established that A causes B, or a causal hypothesis. I surmise that A causes B, together with an explanation of the causal law or the hypothesis that explains how A causes B. Note, the term the term general theory is often used for more wide-ranging theories, but all theories are by definition general to some degree. So some people use the word general theory like this is a big, big, broad theory, right? Something broader. But all theories are general in the sense that they're saying something about some relationship. They're saying about a general relationship about the thing that A causes B. And that this is going to be true for all the similar things in that situation. So it contains what? It contains a causal law or hypothesis, causal hypothesis, together with an explanation explaining that causal law, explaining how that causal law hypothesis, how it does what it does. Explanation. The causal law or hypothesis that connects the cause to the phenomena being caused. So the causal law that connects the cause to the phenomena being caused, seeing how causation works. In other words, the explanation is A causes B because A causes Q, which causes R, which causes B. In other words, the explanation. Why does it do what it do? Now, there might be a process that explains what it does, but it is a kind of another kind of a causal law or hypothesis that connects the cause to the phenomena being caused, right? This being that to that. Antecedent condition. Now, he goes, this is a term from Heppel, right? And others. The term antecedent means anti means anti means before, the sedent, the thing, merely means that the condition present precedes the causal process, and that it activates or magnifies. Antecedent conditions need not precede the arrival of the independent variable onto the scene. They can appear after the appearance of high values on an independent variable that they activate or magnify. In other words, it precedes the causal process. It is something there on the thing that is affecting that and then therefore affects why the causal process causing it to have either higher or lower. Uh, uh, it says it appears on high values or on the independent variable that they activate or magnify. Right? Usually, therefore, on the independent variable, he says. Any seating condition, a phenomena whose presence activates or magnifies the cause of a causal law or hypothesis. Without it, causation operates more. In other words, without it, causation operates more weakly. A causes B if C is absent. More B if C is present. In other words, A causes some B if C is absent, but more B if it is present. Sunshine makes grass grow, but grass grow, but causes large growth only in fertile soil, or not at all. If A causes B, if C is present, otherwise not. E.g., sunshine makes grass grow, but only if we get some rainfall. Right? That's another cases. Right? Example. Right? Some rainfall. Sun makes grass grow, but but only if we get some rainfall. Without that, we don't get that. Right? This is antecedent conditions. We can restate an antecedent condition as a causal law or hypothesis. We can, in other words, a causal. It can be like again, we can. It can be not only like this, but we can then restate it again as a kind of causal, another kind of causal law. So these causal laws are within. In other words, there's not only is the causal law at the level of a law, the general point being made, right, but also in the explanation itself, right? There is some kind of causality. Again, explaining how causality and therefore how it's working. Therefore, this may be a causal law. But even in the antecedent condition can be expressed as kind of a causal law. Also, it's a mini causal relationship because if this is there, then this is going to change this how this works, right? So if we restate the antecedent condition as a causal law or hypothesis, C causes B if A is present, otherwise not. Rainfall makes grass grow, but only if we get more sunshine, right? Antecedent conditions are also called interactive terms, initial conditions, enabling conditions, catalytic conditions, preconditions, activating conditions, magnifying conditions, assumptions, assumed conditions, or auxiliary assumptions. Right? These are some of the ways people often refer to it. But it's this one. Now, we got the main process of what the products of what theories are. Right? The theories are one is a causal law, causal laws, explanations, antecedent conditions. And theories are composed of all three. A hypothesis or a causal law, an explanation plus an antecedent condition. Right? These are the parts of a theory. Okay. Causal law, again, remember, is kind of like the process of A causes B, the general principle. The explanation is why, how A causes B. And antecedent condition is some impact, something that makes this A, affects the way A does what it does, either making it more or making it less. Its presence or absence either makes more or less, or intensifies or it affects it in some way. Now we're coming into another problem. What's a variable? We're going to be going about what is a variable. We mentioned about this about the independent variable. What is a variable? A variable is, okay, and I think this is the thing. I think this is where he's a little weak. I would say, listen, before we get here, we have to distinguish between concepts and phenomena. Huh? What do you mean? Um, he's talking about phenomena. We've already been talking about phenomena. Is what? What is phenomena? Phenomena is the things we observe in the world amongst us. It is the things that are in the world that we observe and type and classify. We'll classify them, type them, and we'll make them being similar or different. We'll put them in classes. We'll kind of assert them in classes and things, and therefore that is that. Now, concepts are conceptual in the mind. They are abstractions. Usually, therefore, there's a distinction in this sense between a variable and the phenomenon. I don't know, but again, this is the problem. Variable and phenomena are connected. The variable is representing at the level of concept a phenomenon, okay, something observed. So this is kind of like this is a kind of at the conceptual level or the logical conceptual level, looking at the logically, we're looking at kind of formal logic, formal logical level, like a mathematical equation, right? Remember, math. What is math in that sense? Math is nothing but shorthand of explaining things, right? It's mathematical. Those things are simply, we could say the same thing. One plus one with take one item with another item. Now you have two items. Well, one plus one, two, right? We have the same. Therefore, we have the same thing with concepts. Concepts are kind of representations of, okay, we want to at the conceptual level kind of explain things in that sense. So variables are a way that we can have a concept that reflects something, and that a variable has variation, like it says, a concept that has various values, like for example, degree of democracy in a country, or of a country, or the share of the two-party vote for a political party. Now, what is this? Now, this is, I think he needs to go a little bit more with the variable. A variable is like a thing that we have something that varies, right? That means this concept is something that we have some kind of measurement here, and there's going to be variation in it with the different things. It's going to be either the size, the amount, the categories. Things like, let's say, we're looking at the phenomena of age, right? So we create the concept of age. So looking at people for old, young, like this, and we have years, the years of birth, right? Formal things. We can do things, and therefore we have, like, he's 1 year old to 5 years old, 10 years old, right? That we can add a value to it, or something. We can quantify it in some way. We can attach some quantity towards it, or measurement to it. Okay, something that we could then measure, compare, contrast. So variables are mechanisms, are representate. Variables are representing a concept representing a phenomena, and they have to relate to each other. They have to agree. In other words, that there must be an agreement, or in other words, if you're saying this is in other words, it has to represent it. It represents the phenomenon. It is act. In other words, it is saying it is a representative aspect of the phenomenon. So hence, let's go look at the different parts of variables. The classic, of course, is the independent variable, right? Um, uh, a variable framing the causal phenomena of the, okay, independent IV, capital I. The independent variable, the causal phenomena of a causal theory or hypothesis. In the hypothesis, literacy causes democracy. The degree of literacy is the independent variable. So, the independent variable is the agent, of course. Now, I always say, and then the next one is dependent variable, right? This is the major ones. Dependent variable, the variable framing the causal phenomena of the causal theory or hypothesis. In the hypothesis, literacy causes democracy. The degree of democracy is dependent. So, independent, dependent. This independent is the agent cause. A dependent variable is the thing being caused. Now, I always like to say this. How do you understand this? Well, I always tell my students, well, think about it, English language. Well, what do we do in English language? We have the basic sentence, right? A sentence is the basic structure. They have nouns and verbs, right? Nouns and verbs, right? There's the nouns and verbs. Right? Oh, verbs are doing, right? Either being, something is doing, or it's being, right? Is the being, something is. In fact, usually in simple sentence, what would is, you can say you can turn it into a very thing. Um, is doing something, some action or activity. Okay, so saying if somebody's saying something is, Bob exists, right? There's no it is only referring. That's a simple ising thing. But everything else are causal. A causes B, some action done to something. And remember, the subject object is the basic fundamental logic in an English sentence is the subject and the object. The subject is always the actor doing the verb action. Well, understand the independent variable in the same way. The independent variable is always the actor causing the action. And the dependent variable is the thing being acted on. Thing that is being affected or caused by the thing, the agent or the actor, the variable in this case, um, acting on it, causing something to happen. Now, we have more complex variables. Now, this is the intervening variable, INTV, big I, small and TV. What is this? Well, this is a framing variable, a variable framing intervening phenomena, including a causal theory's explanation. Um, uh, 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 Included in a causal theory's explanation. Intervening phenomena are caused by the independent variable and caused by the dependent variable. Now, whether a specific variable is dependent or independent or intervening depends on the context and changes in context. As with A in the statement 1, A causes B. A is the dependent variable. 2, Q causes A becomes the dependent variable. In 3, Q causes A and A causes B. A becomes the independent variable. Okay? So therefore, each variable as it is can be, now it depends on the context of what it's doing. An intervening variable is a variable, an example of this continue is the theory of sunshine causes photosynthesis. Sunshine causes photosynthesis, causing grass to grow. Photosynthesis is the intervening variable. In a variable, intervening variables are it is both a caused and causing. Dependent variables are only caused. Caused. Dependent variables are always caused. Something it doesn't cause. An independent variable is only causing. Okay. So it's acting when a variable can be different contexts. This variable in some contexts it can be a cause, independent, only causing, or in other cases it can be something that is caused by something and we're not looking at anything further to it. Or it can be something that is caused by something else, but then causes something else. And therefore, the intervening variable is something that is both caused by something and is causing something. Now we come to these other variables. Now, this is confusing a little bit. People get confused by this. Well, why do we talk about this? Because I think a conditional variable, number 7. Conditional variables are also known as suppressor variables, meaning that controlling variables are those variable suppressors, irregular variations between independent and dependent variables. In other words, there's some condition at play in here, and therefore it's going on. A variable framing the antecedent condition. In other words, this is a variable that frames an antecedent condition. So usually this is going to be an independent variable, or if it's it can be an independent intervening variable. Rarely it's going to be the dependent variable, right? But it can be. You can have it. But I don't think really. I don't think that's the case. Mostly, it's a variable. In other words, condition variables. All these other things can be just a simple variable, or it can be a condition variable. In other words, a variable framing an antecedent condition. The values of a conditional variable governs the size of the impact that the IV or the INTV will have on the DV and other NTDVs. In other words, so it depends. Okay, you can have a simple sentence: IV causes DV. IV int v dv, or IV int v dv. In other words, you can have it can grow on the number of int v's can grow. A conditional variable means that there is going to be in other words, he says, if hypothesis, for example, in the hypothesis, sunshine makes grass grow, but only if we get rainfall. The amount of rainfall is a conditional variable, right? So, sunshine grows grass, sun, grass, rain, amount of rain. Okay, that's interesting. That a sun, grass, the rain is on that. It's really something that's affecting it, occurring at grass level, not at sun level, right? It is another cause, something there that's that the ground. Sun hits the ground. Sun causes grass to grow. Grass is in this is the this sun. If there's no water, grass grows little. Lots of water, if it's got too much water, maybe grass grows, but a certain amount of water, the grass grows higher when there's no water. So conditional variable is a variable that's that frames an antecedent condition. And usually antecedent conditions are found in the independent variables or intermediate variables. Intervening, very nice, intervening. I would say intermediate, intervening, right? Study variables. A study variable is a variable whose cause or effect we seek to discover in our research. In other words, it is the variable we're studying. That's what it means. It can be, in other words, a project study variable can be either an independent variable, dependent variable, intervening variable, or a CV. In other words, now again, this is where it's confusing. CVs can be IVs, DVs, but they have a antecedent condition attached to it. Okay. You can therefore also be paying attention to this conditional variable, not so much the thing that's being done here, right? Now, what is the prime hypothesis? Now, this is interesting. The prime hypothesis is the overarching hypothesis that frames the relationship between a theory's independent and dependent variable. So, this is the hypothesis. This is the hypothesis that A to this. How does the IV connect to the DV? And usually you explain you spell out the causation and you give an explanation, right? Hypothesis always kind of acts like a theory in this sense, right? A theory and some people say, well, a causal law, but yeah, hypothesis we would like this. An explanation, in other words, a prime hypothesis just it frames the relationship between the independent variable and dependent variable. That's the hypothesis. But then an explanatory hypothesis, the intermediate hypothesis that concludes the theory's explanation. The last four terms, conditional variable, study variable, prime hypothesis, and explanatory hypothesis, are my own nomination to fill the lexicon. In other words, the prime hypothesis studies this, is the main overarching one. The explanation is it explains the intermediate, why the intermediate hypothesis that concludes the theory's explanation. And a test hypothesis is the hypothesis we test the test. It's also the research hypothesis, right? The conditional variable, he goes, that's his own explanation of this. He coins the term. That is a variable that has the effect of the antecedent condition. It frames the antecedent condition. Now, this is the basic process. Now, a theory then is nothing more than a set of connected causal laws or hypothesis. Now he goes for different views. See Waltz. To Waltz, theories are not mere collections of laws, but rather the statement that explains them. These statements include theoretical notions, which can take the form of concepts or assumptions. I prefer my definition to Waltz because all explanations for social science that I find satisfying can be reduced to laws or hypotheses. His definition of explanation lacks precision because it leaves the prime elements of a explanation unspecified. For a third meaning, the more restrictive than mine, see Auchins and Sindels, a theory is a very general set of propositions from which others, including laws, are derived. Their definition omits modest general ideas that I call theories. Near to my usage is Heppel's, right? He says, and it goes on to the quote. He says, a quote from Heppel. So let's go like this. So theories are nothing more than a set of causal laws or hypotheses, right? We can always arrow diagram theories like this. Remember what an arrow always means causality. An arrow signifies the direction of causality, right? The arrow points, the tail of the arrow is the agent causing, and the direction, the arrow points to the direction of causality, right? So A causes Q, which Q causes R, causes B. Independent variable, dependent variable, intervening, right? So in this diagram, A is the independent variable, B is the dependent variable. The letters Q and R indicate intervening variables and compromise the theory's explanation. The proposal A causes B is the theory's prime hypothesis, while the proposal that A causes Q, Q causes R, and R causes B are its explanatory hypothesis, right? Explaining it. That A causes B. Q, in other words, like this. We can add conditional variables, indicating them by using the multiplication. We can add conditional variables, indicating by using the multiplication syndrome. Here, C is a conditional variable. The impact of A on, again, this is the framing. A conditional variable is an antecedent condition. That it frames the antecedent condition that affects A. And actually reading this now, I'm always correcting myself. I've been teaching this so long that I even simplify this. I think this is good. He's doing it this way because it clarifies it. Most times, simple things of A, B thing, and then A is conditional variable of this. He understands a conditional variable as separate. I've always understood that. I read it this way, so you don't have to have this. See, I think this can be a little bit confusing, but I understand why he does it. See, this is the C. C is the conditional variable, which the antecedent condition causes A, which then causes Q, cause R, cause B, right? He says you call it's indicating them by using the multiplication X. Now, a multiplication sign here is used only to indicate that the CV magnifies the impact. It does not mean that the CV literally multiplies the impact. Oh, it might. I think that's why I don't like this, because we see the X, we think that. But okay, I think he's saying here, this is what this causes. He goes, the example would be amount of sunshine causes the amount of rainfall, the amount of photosynthesis, amount of grass growth, right? So this with this causes this. This impacts that. But this impacting that causes this, which this then causes that, right? One can display a theory's explanation in any level of detail. Here I have elaborated a link between R and B. So to show explanations, in other words, to show to show explanatory variables S and T. So a Q, R, S, T. In other words, explaining each stage of the process. In other words, this process can extend of this each level of the process that leads us there. Right here, the extended one can extend the explanation to define more remote causes. Here, the remote cause of A, Y, and Z are detailed, right? So here, Y causes Z causes A. But then C has an impact which then relates to Q, relates to R, then causes S, that causes T, that in turn causes B. We can detail the causes of the conditional variable here as here with this cause of C. So here X causes C, but C impacts um, um, Y causes Z and Z causes A. But C is the conditional variable impacting A, which then in turn causes small q, which in turn causes small r, which in turn causes small s, which in turn causes small t, and causes small. Now this and this are intermediate variables now. They're no longer, this is the independent variable here. This is the dependent variable. Independent variable is always the initial one. It's never. This is now being a cause. This is intervening. Now here is a very complex model. There is no limit to the number of antecedent conditions we can frame. Here, more conditions, D, U, and V are specified. In other words, oh my God, this is a monster mess. Ready? No limit. This is another. This is a this is a big monster, right? This is Y causes Z, which causes A. But here, A has the impact of D affecting C. If conditional variable D with antecedent condition in D impacts C, which is the antecedent condition, was caused by X. X causes C, but impacted by D, which then impacts A, which has been caused by Z, previously caused by Y, right? Now, this A impacted by these things, this process, causes Q, causes R, causes S, but then S, S, well, V impacts or has impact, is a CV that has impact on U, then U has an impact on S. So these things affect this. So therefore, this is condition here, conditions this conditions that. Then we have S to T, and then T causes B. Independent variable, dependent, intermediate variables, conditional variables, right? Independent. This is the independent. That's dependent, but it's in terms of a conditional variable. You can study each one of these on the terms. This is causing that. This is just a variable. This is a variable impacting that, not causing. It's kind of a causing, but it's affecting more than that. One can add more avenues of causation between causal and cause variables. Here, two chains of causation between A and B. So, here, two chains of causation between A and B. Running through the intervening variables F and G are added to produce a third chain theory. So, this is a mess. This causes this, but it does through this process. It either goes this process to F, or this process to G, to B. So A goes to F to B, A goes to G, then to B, A goes to Q, then to R, then to S, which, okay, this is my birth. I'm even ignoring this problem right now. X goes to Z goes to A, but A has impacted by C, which came from X. X causes C. Here, D affects C that has been caused by X, which then in turn affects A. A either goes this way to F, then to B, goes this way, causing F, then to B. B, A can go, in other words, but by this way, the argument usually means what happens here is how these affect that, and then turn affect that, leads it to go either this way, or this way. If it goes this way, it goes to F, A causes F, which then in turn causes B. Here, A goes to G, which then causes B. A then goes to Q, which goes to R, which goes to S, but S has been impacted by U impacting V impacting U, which then impacts S. This is an interesting variable, a conditional variable that conditions this variable, which then in turn condition this variable, which then causes that variable, and then T then causes B. So he's really giving us the big mess right here. This is that these three things are three directions. Usually, and he doesn't explain how this works. He just offers it. I think this is a little not nice of him in that sense, because this is a little confusing. Like, what does this mean? That's why when I teach undergraduates, I normally don't go into much detail about this, because I usually skip this in that sense. Because what he's saying here, how this explanation of this, how this works, given this process, affecting this will lead to either to go here, here, or here. Okay. These things, how they varied, what is done at these stages, and the effect of that will lead to different results here, which then leads to different outcomes to B. These are multiple causal chains. A goes to F, then affects B. In other words, it goes this way, then this way, this way, this way. Then, this is a multiple we call avenues of causation. This is very complicated. A theory cannot be a theory that cannot be diagram is not a theory, and needs reframing to become a theory. This is very important. If you can't diagram it, then you've not clearly done it. A theory that cannot be diagrammed is not a theory and needs reframing to become a theory. According to this criteria, much political science theory and theory writing is not theory. Right? In other words, if you can't diagram it, you can't make it a simple diagram. In fact, this is the difference between political theory, as we know, political philosophy, and political ideas. If you can't, in other words, a lot of it is about justice and claim. But I'd argue even that is kind of making a claim about something, and can be, if you thought about it and carefully did it, it is making a claim about something. In other words, it's often sometimes making a meta cause, not a specific cause, but sometimes is making a specific cause. So therefore, this is why according to this criteria, much political science theory and theoretical writing is not theory. And I think this is interesting. And I think he means this at postmodernists. He's really taking a crack at postmodernists, I think, here in that sense, right? Because there's no causal relationship, right? Now, I'm going to finish this with the specific explanation because this is, we moved it from this to this. What is a specific explanation? Explains explains of specific events, particular wars, revolutions, election outcomes, economic depressions, and so on. Uses theories that are framed like theories. Uses theories that are framed like theories. A good explanation tells us what specific cause produced a specific phenomena and identifies the general phenomena from which the specific cause is an example, right? So, in other words, we have three concepts we are mentioning in this regard. So a good explanation tells us what a specific cause. A good explanation tells us what specific cause produced a specific phenomena and identifies the general phenomena of which this specific case is. So the specific thing is part of a larger phenomenon, right? A specific explanation. An explanation cast in specific terms that accounts for a distinctive event. Like a theory, it describes and explains cause and effect, but these cause and effect are framed in a single terms. Did I skip something? "12, 13, 14, 15. Thus, expansionism causes war. Expansionism causes aggression, causes war. Is a theory. Okay. Thus, this expansionism causes war. Uh, 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 Expansion causes aggression, and aggression causes war. Is a theory, right? German expansionism caused by German aggression, causing World War II, is a specific explanation. Specific explanations are also called particular explanations as opposed to general explanations, right? So it's particular versus general, right? A general one is, we'll talk about this, is um, something that is very um, well, it's something that's more general phenomena, right? The general thing, general explanation. In other words, specific explanations are particular; they're very specific rather than broader. In other words, this is the theory, the explanation of theory up there, but this is going to explain it in the specific case. The general explanation is the explanation at the level of the theory. Here, you're looking at the specific case, right? The specific case, a specific phenomenon, the detailed, the specific instant or case you're looking at, right? The particular event, right? In that sense. So German expansionism is a form of expansionism. German aggression is a type of aggression. This is the specific. This is the general. And World War II is the specific war, and war is the general concept of, right? Now, specific explanation come in two types. That is non-generalized specific explanation and specific explanations. The second type, general specific information, is more useful. Non-specific, non-generalized specific explanations. A specific explanation that does not identify the theory that operating the cause for the example. Germany caused World War II. This is a non-generalized. Germany caused World War II. The explanation does not answer the question of what Germany is an example of. Now, such explanations rest on implicit theories. However, as Carl Hempet has explained, sometimes these things are implicit theories, implied. No, it's never good to just write implicit. You need to explain. That's why this is like this. Now, a specific explanation is a specific explanation identifies the theories that govern its operation. German expansion caused World War II. Right? That's the generalized explanation, right? German expansionism caused World War II. The operating cause, German expansionism, is an example of expansionism, which is an independent variable in the hypothesis expansionism causes war, right? So again, that general thing is this generalized specific explanation. German expansionism caused World War II. The operating cause, German expansionism, is an example of expansionism. This is the specific case. This is the general case, right? Here, there's a generalized thing that this is causing this, and it's not. A non-generalized one is it's something you don't know why it's doing what it's doing. What Germany is an example of, right? Here, German is a specific case of expansionism, which is expansionism. Is the independent variable in the hypothesis expansion causes war. Now, specific explanations are composed of causal. Now, specific explanation. Now, this is when I'm doing explanations, right? Specific explanations are composed of causal, caused, and intervening phenomena. Causal phenomena, causal phenomena, CP, the phenomena doing the causing, the cause phenomena, the phenomena being caused, the intervening phenomena that forms the explanation, right? The intervening from that forms the explanation. These are caused by the causal phenomena, and the cause, the outcome phenomena. So this is the initial cause phenomena. That the intervening is what. These are things that are what. This is kind of like the CP, the independent variable, dependent variable, intervening variable, right? And the antecedent phenomena is a phenomena whose presence activates or magnifies the causal of this. So again, the concept, phenomena is the specific. Now when we're looking at, he's calling phenomena here specific things. In other words, he's looking at the specific. We're looking at a specific case. We're looking at the things in the world, that class. Specific are composed of causal, caused, intervening, and entities and phenomena. Now, theories thus, in other words, specific explanations are composed of singular phenomena that represent specific values on variables, not of variables themselves. In other words, these things are composed of singular phenomena that represent specific values on the variables, and they're not the variables themselves. As such, they are phenomena, not variables. On assessing, in other words, how can this be explained? In other words, how can specific events be explained? We'll see that later chapter. In other words, that this is affecting that, but it's not that. It is. In other words, this is going to be. In other words, he's saying a singular phenomena represents specific values on variables, not of variables themselves. Not of variables themselves. So therefore, these things are impacting or aspecting the variable. So are composed of singular phenomena, right? That are acting on. They're not a variable themselves. They are such as phenomena and variables. Okay, goes like this. So let's go to the. We arrow diagram specific. We arrow diagrams explanations in the same way we do theories. Okay, right? A theory. Expansionism causes aggression, causes war. Okay, in this theory, independent variable, dependent variable, intervening variable. A generalized specific explanation. German expansionism causes German aggression, causes World War II. A non-generalized specific explanation. Germany, outbreak of fighting on September 1st, 1939, World War II. Okay, there's no this fighting on September 3rd, this is just facts. There's no causal relation, no clear causal relationship to the theory. This is again non-generalized specific explanation. This is specific. It says Germany, date that the war began, World War II. There's no relationship between this and what is it representing. Here, German expansionism, German aggression. This is a specific explanation. So we're going to stop here. This has been our first explanation. Next time we meet with what is a good theory. Okay? If you liked it, like it. If you didn't like it, say that and say why. If you've not subscribed, subscribe. If you like these things, and share them on social media, get other people to do it. Encourage them to subscribe. Forward it. Put the video on social media. Send it to your friends. Encourage them to subscribe. Didn't like it, say that, but say why in the comments. Another thing is, you want to see my links below about my social media links. You want to follow me, you can follow me there. You can see my academic material links there. Links to my academic social media. Then you want to help what I do, you can become a Patreon Subscribe-Star member, or you can find other ways. Another thing you can do is you can buy one of my books that are listed below through Amazon or any such distributors. You buy the Lulu one directly from Lulu, I'll make more money, but that's it. Okay, that's it. Well, again, next time we meet, we'll be seeing this. We'll look at the question of what's a good theory, right? We'll continue on this. Take care. Bye-bye.